Solving systems using matrices. This is just another way of solving systems of equations. It's not one of the more popular ways, but it's one that it's important to try to understand anyway. I will say the steps here are very vague because this is honestly a skill that is so much easier to understand by seeing it done rather than just reading the steps. So if you'd like to pause the video and go ahead and copy down the vocab and the steps, then you can do that. But working through this will make it so much easier. So I'm going to zoom in while still reading through the steps. So step 1 is to rewrite each equation in standard form. So this one will become 3x plus y equals 4. And this one will become y minus x equals 4. So what we're going to do is, but I had this backwards, so let me erase super quick. So the negative x, should be first, plus y. Now, your second step is to write the coefficients to the left of the equal sign in a matrix. So we're going to have our matrix, and our coefficients are simply 3 and 1, and negative 1 and 1. That's it. And then your solutions, and this should be negative 4, are negative 4 and 4, and you write them out here. What you do next is you are going to flip these two, meaning swap them out, and then you're going to change the signs of these two. So we're just going to rewrite this again, another matrix, except the 3 and the 1 will be flipped, and the signs here will switch. So since the top one is positive, it'll now be negative. The bottom one is negative, it will become positive. Now you're going to cross multiply. So you're going to multiply this here, and then this. So you're going to end up with 3 minus negative 1. So you always have a minus here. So sometimes when you multiply and you get a negative, that counts as the subtraction sign, and that's not the case here. So 3 minus negative 1 equals 4. Now this is going to become your inverse. That was step 3, is to find the inverse. And now we're going to multiply. So the 4 is actually going to be written as the inverse here. Is what we're going to write it as 1 over 4. We're going to bring over this exact same matrix that we used right here. So we're going to have the 1, the negative 1, the 1, and the 3. We'll close it up. We'll have our negative 4, 4, and a vector over here. And now you multiply. And the way you multiply is you think of these as your x's, and these as your y's, and this is your x, and this is your y. It's not exactly what they are, of course, but it's easier for me to show you if I give them a little bit of a name. So you're going to bring down your 1/4, and now you're going to multiply. So we're going to take 1 times negative 4, 1 times negative 4, and then you're going to and then you're going to do negative 1 times 4. Okay, so basically you're taking the first number and you're multiplying it by the top number in the vector, and then the second number is being multiplied by the bottom number in the vector. So we're also down here, 1 minus negative 4 again, times negative 4 again, and this time we have a positive 3 times that 4. So you have 1/4 times, what you're left with in here is negative 8 and 8. So what you do is you multiply the 1/4 by negative 8. It's kind of like the distributive property. 1/4 times negative 8 is negative 2. 1/4 times 8 is 2. So it looks pretty confusing. There's a whole lot going on here, but once you get the hang of it, it's not quite as difficult as it seems. So let's come over here. Once again, we're going to take, I'll highlight them for you, just your coefficients. Symbols are included. Okay, and we're going to rewrite those or write them into a matrix with this on the outside. Okay, so remember, you're going to flip these two and then change the signs of these two. So we're going to come down here, and this time the -3 and the -2 are switched. And since both the 8 and 9 were negative, now they become positive. You're going to cross multiply now. So -3 times -2 minus 8 times 9. And I end up with 6 minus 72, which is -66. So that is going to become our inverse. And we're going to bring over this matrix, the -3, the 9, the 8, the -2, with our 26 and -28 out here. And we're going to do our multiplication. So you have -3 times 26 plus 9 times -28. 8 times 26 minus 2 times -28. So you end up with, oh, and I'm sorry, this should have been a -66 here. So you end up with 1 over -66 times 330, -330 over 264. And this is just this simplified. So -3 times 26 plus 9 times -28 is -330. And then again, you just distribute 1 over -66 times 330, which is just 330 divided by -66 is 5. And then 264 divided by -66 is -4. Okay, we'll go through 2 more of these. So I'm going to try without all the highlighting this time. So -9, -6, 3, and 4. Let me move this a little closer. And -3 and -7. So we're going to flip-flop these and then change the sign of these. We're going to cross multiply, so 4 times -9 minus -3 times 6. So you end up with -36. Let me see. Minus, sorry about that, -18, which is -18. 1 over -18. And then we have 4, -3, 6, -9, -3, -7. 1 over -18. 4 times -3 plus 6 times -7. -3 times -3 minus 9 times -7. And once all that is simplified, going straight across, you end up with -54 and 72. -54 times 1 over -18, or -54 divided by -18 is 3. And then 72 divided by -18 is -4. Last one. Original matrix is -2, -2, 1, 4. On the outside, we have -4 and -13. We're going to flip-flop these. We have 4 and -2. We're going to change the signs of these. Cross multiply. 4 times -2 minus -1 times 2, which ends up being -8 minus -2 or -6. 1 over -6. And then we have 4, 2, -1, -2 in the matrix, -4, -13 on the outside. 1 over -6, 4 times negative 4 plus 2 times negative 13, negative 1 times negative 4 minus 2 times negative 13, 1 over negative 6. Multiply, add straight across. You get negative 42 over 30. And negative 42 divided by negative 6 is 7. And 30 divided by negative 6 is negative 5. So there you go. They're solving systems with matrices. And hopefully this was easy for you to understand.